So, previously I had stopped after describing in details the interference science to you, and then a natural progression of that is holography, as I had told you, because holography also includes many of the principles of an interference pattern and how the interference patterns is formed. So, I will devote the next few lectures to holography. Now, when you think of holography, what comes to your mind? Immediately you think of three-dimensional picture, you know, a object represented as a three-dimensional image. Okay. So, that is what comes to your mind, and we will see how that three-dimensional effect is brought about. Actually, three-dimensional illusions can also be brought about by many other methods. Like you see the three-dimensional films in a movie theater. Okay, that is not the technique which I am talking about. They are called three-dimensional films, and they do give you that illusion of a three-dimensional effect. But then that is dependent on the fact that your two eyes are seeing two different aspects of the same picture. That concept is used there, and the concept that how do you get an image to give you a different view of the same image to the left eye and the right eye. They do it by using Polaroid films. So, you know that in a movie theater you have to wear those Polaroid glasses. Okay. So, holography is not that. That is not the way we are going to get a three-dimensional picture. Okay. And many years back I had seen that we used to see a lot of three-dimensional postcards, if you remember. So, they gave impression of a three-dimensional effect. That means the picture is sort of coming out of the page, that kind of a thing. Again, that is not the principle of holography. In that, the principle was you have ridges on the picture, so that you have tiny prism-like structures formed on the film. And the different surfaces of that prism gives out a reflected and a refracted ray, which gives a kind of a displacement of the picture that is below that prism-like thing. And again, your two eyes perceive a different part of the image, and that is how your brain thinks of it as a three-dimensional picture. So, when I talk about a three-dimensional picture, what we need to know is that we need to know the depth of an object. When we photographed an object, we do not usual kind of photograph, whether you take it on your mobile phone or you draw a picture seeing it, or you take a usual kind of a photograph and develop the film, and it is like that. So, those are all two-dimensional pictures, and you do not get an idea of the depth. Okay. So, you get an idea of the depth. The moment you get an idea of the depth, you know it gives you that feeling of three-dimensional feeling. So, in a usual photography, that depth part is missing. So, let me just compare a usual kind of photography and how holography is different from that. So, a photographic plate records the intensity of the wave. The information concerning the phase of the wave is lost in this process. Okay. Thus, a photographic plate conveys only a limited information of the object. That is why you do not get the perception of the depth, because some information is missing. In particular, there is no information about the distance of various parts of the object from the photographic plate. In other words, an ordinary photograph does not allow a complete reconstruction of the wavefront registered on it. Okay. So, in a usual photograph, you are only looking at the intensity pattern that the photograph is, that the object is giving you. You are not looking at anything more than that. But definitely something is missing, because you are getting a two-dimensional picture. The third dimension is somehow missing. You can always create a illusion like very good artists do, with light and shadow. They create that illusion of a three-dimensional picture, but again, it's not good enough. Okay. So, there is this some more information which is to be recorded, and that is given by a hologram. So, holography helps in removing this little drawback of photographic method, and in recording on a photographic plate information about the amplitudes of the wave incident on it as well as their phases. So, the information that was missing in case of a ordinary photographic plate was the phase part. The amplitude was measured, because you are measuring you are recording the intensity pattern, okay? And amplitude square is the intensity. In other words, complete information about the wave forming the pattern can be recorded by using holographic techniques. The wave reconstructed with the help of such a recording is completely identical to the original wave and contains the complete information carried by the original wave. So, one can say in a more scientific way that there is some information that is missing in an ordinary photographic plate or an ordinary photograph. But in case of a hologram, or in case of a holographic plate, a certain plate, it has some more information, which is the phase part, okay, which is included in this. So, that is the difference between the two. Of course, we will go through and see how we can get, how we can record and how we can get a picture of such a three-dimensional structure. Okay. That is what we will be doing today. So, here if I say, suppose this is a photographic plate. Okay. So, you have just recorded the intensity which comes out from the object. These dots are the intensities, and those dots, dots or pixels in case of a in case of a digital picture. Each of those pixels are used, and you make a picture out of that. So, it is only the intensity. There is no phase recorded on this, That is why you do not get that perception of depth in a photograph. But in case of a hologram, you have been able to record even the phase, but how? So, if you look at a photographic plate, you will see some picture, maybe a smiley face. Okay. But the same smiley face, if you see on a hologram, it is just going to look like an interference pattern. It is not going to look like that smiley face, but you have to do something more to it in order to reconstruct that smiley face. Okay. So, a hologram does not look anything like the object that you are trying to reproduce, but still it is able to reproduce it under certain conditions. Okay. So, let us see how it goes. Okay. So, actually one can say that in case of radio engineering, many years back, much before holography came into the picture, the engineers were really sending informations from one place to the other by coding a wave, into another wave. Okay. So, they had a very high frequency. These are what the radio engineers were doing at that time. Okay. So, they had a very high frequency wave. On this wave, they would embed another low frequency structure. Okay. So that the final thing would look something like this. So you had a high frequency wave on which this low frequency, this part, was overriding that wave, or embedded in it, or coded into it. And then at the receiver end, you could have a filter which filters out the high frequency, and just the low frequency part is remaining. So it is like encoding something into a carrier wave. Okay, and then you can decode it. So holography is, if you have an analogy between these two, then you could say that there is a carrier frequency and a signal frequency. Okay. So in case of holography, that is called the reference wave and the signal wave. Okay. So that's the analogy between the optical part and that radio frequency part. So here let's see just the basic concept. Basic concept is, here I have a reference beam. This is the reference wave. It's a beam of light. Okay, and it is coming through here. There's a mirror here, so it reflects back. Okay, and then you have another wave which may be part of this this wave itself, which illuminates the object. This is my object. This is what I want to reproduce. It illuminates that object, and then the waves that come out from this object and this particular reference wave, these two interact with each other. They interact with each other and they form a pattern which is recorded on this holographic plate. So I can call this reference beam, the analogy is with the carrier, high frequency carrier wave, and this beam is the signal. So I have a interference between these two, and the interference is coding, in a coded way it is writing on this holographic plate everything about this object. Okay. Now the second part of this is, so here is the holographic plate, I will call it the hologram, and I have shown it here. So I have the hologram, then you pass another beam of light through this hologram. Okay. Through this hologram you pass a beam of light, and this beam of light gets diffracted, through this pattern. The pattern has some effect on this wave, this is something like a reference wave, and then it disperses out here and here. And what your eye can see is a virtual image of the object which is formed here, and you can get a real image also here. So when you look into the hologram, you are seeing a virtual image. Your eye is seeing that virtual image. Okay. Now this will look exactly like this object here. Okay. The holographic plate itself, if you were to just look at it, nothing much would happen. It would just look like plain lines. But you hold it when you have a reference beam, then you see the actual object which comes in. Okay, so as we just go along, you will understand it even better. So I have just put in a small file here, in a small table here, the features and the difference between photographic films and a holographic plate. Okay, this records the intensity pattern. Remember that intensity, and intensity is square of the amplitude. So I am only basically recording the amplitude of the wave that is coming in, the light wave that is coming in, while the photographic plate here records the interference pattern. Okay. So that's the difference between the two. Then recording mechanism in case of a photographic plate, it is captures light intensity variations directly. You know that. Whatever is the light intensity variation is recorded onto the plate directly. There is nothing much more to be done about it. While in case of a hologram, captures the fine interference fringes. Okay. So if you were to just look at that hologram, you will get interference fringes there. You will not see any image. While in case of a photographic plate, immediately on that plate you can see the image. Okay. Then in case of photographic films, the films need not have a very high resolution. So the grain sizes means, of course, the photographer's plate is, the film is made out of some certain chemicals. So those grain size of those chemicals is around 1 micrometer to 10 micrometers. Okay. So, okay, if it is close to 10 or little more than 10, it doesn't matter. It doesn't matter. Even if you made it smaller than that, your total impression of the picture won't change much. Okay. So you can afford to have grain sizes which are more than 10 microns also. Okay. So, but in case of a holographic plate, it needs to be high resolution grain size, 0.01 on an average, 0.01 micrometer level. Now why do you need a high resolution there? You need a high resolution there because, see, you are recording some more part of the data other than the amplitude or the intensity, which is the phase. And all that phase information is locked into that interference pattern. So if you don't get if you are unable to, you are getting a very good interference pattern, very fine pattern, but then your photographic plate is unable to record that fine pattern. Then obtaining such a fine interference pattern is of no use. Try to recollect some of your interference fringe that we talked about before. In that, think about finesse, resolution. Okay, we are looking for better and better finesse. We are looking for better and better resolution. So you are able to get a good interference pattern with a good finesse, good resolution, but then you are unable to record it. Okay, just because your recording plate, the holographic plate, it doesn't have the chemical grain size that is really required to record these fine fringes. So now you can understand why the holographic plate should have a higher resolution. Okay. You can afford in a photographic plate to have a lower resolution because you will still get some picture. But in a holographic plate, if you don't have higher resolution, you are giving up on some data itself. Okay. So again, as we go along, we'll understand the importance of this high resolution. Then some of the materials that are used in a photographic film is silver halide emulsions on flexible plastic films. Okay. So here also, in case of photographic plate also, some of the materials used are of a similar type, silver halide or dichromated gelatin on a rigid glass plate. The difference is this can be a plastic film, but this has to be a rigid glass plate. So, as we go along, we will understand why a rigid glass plate is so important for a holographic plate. Okay. Then light sensitivity, lower sensitivity to coherent light, and here sensitivity to coherent light is more of lasers. Okay. So, generally you will get a hologram only with laser light. Actually, when holography was first discovered, it was by a Polish scientist who gave this concept of holography. His name was Wolfke. And he did it somewhere around in 1920. He came up with this idea. And as you know, in 1920, there was the lasers were not discovered at all. So, within a few years, this whole concept was forgotten. All scientists forgot about it and they were not working on it. Then once again, a British scientist, Gabor, spoke about it somewhere in 1948. And by 1960, the laser was invented and holography took off in a very big way. All because lasers had coherent light. And for holography, this condition of coherence is absolutely paramount. And you know that because the whole thing depends on an interference pattern. And you've seen before in an interference pattern how coherence light is important, coherence length, spatial coherence, temporal coherence, all these things are important. So, once lasers came into the picture, holography just flourished. Okay. So, and you know why. Now, then another thing is in case of photographic films, the emulsion layers are thin layers, while in holographic plate, thicker emulsion layers for better phase recording is used. Okay. Again, we will understand this as we just go along. Just remember that in case of a photographic film, a thin emulsion layer is good enough, but in case of a holographic plate, we do need thicker emulsion layers, and we will talk about it. Now, I have just given some properties of that film. I've just written it down, which you know already. Silver halide emulsions capable of capturing the fine interference fringes. Okay. That's the important part, capturing the fine interference fringes. Then photoresist materials that undergo chemical changes when exposed to light, enabling precise pattern formation. Okay. Precision is the key here, okay, of recording a hologram, so that you reproduce the object image very, very well. Okay. Then there are dichromated gelatin for bright holograms for artistic display. So, these are some of the materials that are used, okay, in case of a hologram. So, now let us go ahead to see how this hologram works. So, to start off, we will speak about a hologram of a plane wave. That means we are just going to record the hologram. We are not reproducing anything, we have to just record it. Now, in order to record it, here I start off with a plane wave. Here, this is a plane wave front I have just shown, and k is the wave vector, which is 2 pi by lambda. So, a certain frequency or certain lambda has been taken. I am not speaking much about the lambda as yet, but okay, one of them. And you know, in an interference pattern, we are going to speak about interference pattern. keeping one lambda gives you only one frequency gives you the best interference patterns. Okay, then the highs and the lows of the interference pattern, or the visibility of the interference pattern becomes better if you have a single wavelength. Then here what I've done is I've just placed a prism here. Prism means I just want to divert this wavefront into a different direction. And I don't take a separate beam because I know if I have the same beam, the coherence part will be would have been satisfied. Okay. So I just put a prism and I just divert some part of the beam. So I have a wavefront which is here, and I have a wavefront which is here. These two interfere on this photographic plate. So I want to see what is the interference pattern on this photographic plate. So I'm just, for the moment, I'm just talking, it will give you a good picture. I'm talking about a two-dimensional recording of the interference. Okay. So let's see, we'll go ahead with this in my next lecture. What does this recording look like, and what is the significance of this recording, and how exactly is it made? Basically the concepts behind it. Okay? So we'll continue in the next lecture.